Hello and welcome to my channel. I am Mensa Augustine. Please, if you are new here, kindly subscribe to my channel. And if you have been watching my videos and you have not yet subscribed, please kindly subscribe us to the mathematics community. In this lesson, we are going to differentiate trigonometric functions. And here we are going to use the chain rule. We are going to use the chain rule. So if you have not watched my first video on chain rule, just go and watch that video. That will improve your understanding here. Now, since you are going to differentiate trigonometric functions, we have the first 6 trig functions here. These are trigonometric functions. So if we differentiate sine x, you get cosine of x. If we differentiate sine of an angle, you get cosine of the same angle. Okay, so if I differentiate, let's say, sine theta, the answer is cosine theta. Remember that. Okay, if I differentiate cosine of an angle, it is equal to negative sine of the same angle. If I differentiate tangent of an angle, the answer is equal to secant square of that angle. If I differentiate secant of an angle, the answer is equal to secant of the angle times tangent of the same angle. That is what we have there. Okay. Now, let's take some questions here. I have 6 questions here to improve your understanding. Let's take f of x to be equal to cosine 5x. Now, here, the angle here is 5x. So this is a composite function because the cosine is also containing another function, that is 5x. The angle there is a function. So we are going to use the chain rule. Now, if we let u to be equal to the inner function 5x, then f of x now is equal to cosine of u. Very, very simple as that. So, the derivative of u with respect to x is equal to, if you differentiate 5x, you get 5. Now, the derivative of f of x with respect to u is equal to, if you differentiate cosine of this angle, you get negative sine of the angle. You have minus sine, and the angle u is equal to 5x. As the derivative of f of x with respect to u. So from the chain rule, the derivative of f of x with respect to x is equal to the derivative of u with respect to x times the derivative of f of x with respect to u. That's why I said that if you have not watched my video on the chain rule, check the description for that video. So here, du dx is 5 times the derivative of f of x with respect to u is minus sine 5x. Put this into bracket because of the minus sign, else you take it as subtraction. So we are going to have minus 5 times sine 5x. You can put the angle in bracket or you can leave it without putting it in brackets. Very, very simple as that. Okay, let's take another question. Now, if we consider h of u to be equal to cot u a minus 2. Now, how do we differentiate this one? Okay, so here we are finding h prime of u. That is, you are differentiating h of u with respect to u. Okay, so anything that is not u becomes a constant. So we will let, here we have u, so we can't let u equal to the inner function. So we choose another variable. You can choose y, because we don't have y here. You can choose x, you can choose anything. So I am choosing m. Let m equal to ua minus 2. Then the derivative of the derivative of m with respect to u is equal to a. If we differentiate ua with respect to u, a is a constant. So it is like writing ux, y equal to ux. So here the derivative of y with respect to x is equal to, take the constant u. Simple as that. It is like writing y equal to 2x. The derivative of y with respect to x is equal to, take the constant 2. So here, if I have ua, it's the same as au. So if I have y equal to au, then the derivative of y with respect to u is the constant a. Take note of that. We have always been dealing with x. So if you change the variable, you become confused. Simple as that. And let's say that if I have y equal to, let's say ua, if I differentiate y with respect to a, then the answer is u. Take note of that. Okay. So here, if you differentiate a constant, it is 0. So the derivative of negative 2 with respect to u is 0. Now, we have our h of u is equal to cot m. That's the cotangent of m. Now, how do we differentiate cotangent? That is what we have here. The derivative of cotangent of x is equal to negative secant squared of x. So, here, the derivative of u with respect to m is equal to negative secant squared of m. And that is equal to negative secant squared of m is what? M is ua minus 2. So, the derivative of h with respect to u is now equal to the derivative of m with respect to u times the derivative of u This is the derivative of h, rather. Yes, correct. The derivative of h with respect to m. That's correct. So here, we are going to have a times negative secant squared of ua minus 2, which is equal to negative a times secant squared of ua minus 2 as our h prime of u. Very, very simple as that. So here we differentiated h with respect to m, or h of u. You can call it h of u, or you can leave it as h with respect to m, not u with respect to m. Because the function here is h of u, right? So you can write it h representing h of u, or you can put the u there. There's no problem with that. Very, very simple as that. So here, h prime of u simply means that differentiate h with respect to u, or h of u with respect to u. Very, very simple as that. Now, let's take the next example. Now, next example, we are going to take y equal to secant of 5x squared minus 3x plus 2. So let's see. If we put u equal to 5x squared minus 3x plus 2, the derivative of u with respect to x is equal to, if we differentiate 5x squared, you get 10x. If we differentiate minus 3x, you get minus 3. Now, we have this imply that y is equal to secant of u. So the derivative of y with respect to u is equal to, if we differentiate secant, what do you get? You get secant times tangent. So here, the derivative of secant of u is equal to secant of u times tangent of u. Very, very simple as that. Now this gives us secant of u, that is 5x squared minus 3x plus 2 times tangent of 5x squared minus 3x plus 2. Very, very simple as that. So now, we can now take du dx times dy du. So here, our dy on dx, the derivative of y with respect to x is equal to the derivative of u with respect to x times the derivative of y with respect to u. And this will give us 10x minus 3. Please remember to put it in brackets because we have two terms. Times secant of 5x squared minus 3x plus 2 times tangent of 5x squared minus 3x plus 2 as the derivative of y with respect to x. Remember that if you differentiate, the answer is called the gradient of the function. So if you are to find the gradient of this function, then this is the gradient of the function. Wow. Let's take the next example. So let me take the example that we've done. We've done this. We've done that. No, we've done this one. So let's take the next example. Now, the next example, we have y of x is equal to sine. You have sine of 7x squared plus 2. So here, if we take u to be equal to 7x squared plus 2, the derivative of u with respect to x is equal to, if you differentiate 7x squared, you get 14x. If you differentiate plus 2, it's a constant, so you get 0. Now, this implies our y of x is equal to sine of u. So the derivative of y with respect to u. So here you can put the derivative of y of x with respect to u, or you can just take it as y with respect to u. Is equal to, if you differentiate sine u, you get cosine u. If you differentiate sine of the angle, you get cosine of the same angle. So the derivative of y with respect to u is now equal to cosine of u, and u is 7x squared plus 2. So the derivative of y with respect to x from chain rule is equal to the derivative of u with respect to x times the derivative of y with respect to u. Why are we saying it is a chain? See, you have dx, dy, du, du. It will go here like that. So we take du dx, that is 14x times dy du, that is cosine of this. So let me put it there, times cosine of 7x squared plus 2. Very simple as that. Now, let me take that one too. We've done this. So we are left with 3 examples for us to go. Now, let's take our h, gen of A to be equal to gen of theta. Gen of theta to be equal to cosecant of 3 theta minus 4. So here, if I let u equal to 3 theta minus 4, the derivative of u with respect to theta is equal to 3. If we differentiate 3 theta, you get 3. Negative 4 is a constant, so if you differentiate with respect to theta, you get 0. So this implies that gen of theta is equal to cosecant u. Now, the derivative of gen with respect to u is equal to, if you differentiate cosecant u, you get negative cosecant of u times cotangent of u. Remember that in some book they write the cosecant as CSC, and in some book they write the cosecant as this. So the same thing. If you write CSC, it means cosecant, and if you write cosec, it's the same as cosecant. So don't be confused. Now, this will give me negative cosecant u, and what is u? 3 theta minus 4. We have two terms, so we have to put it in bracket. 3 theta minus 4 times cotangent u, and u is 3 theta minus 4. So the derivative of gen with respect to theta, that is to write gen prime of theta, is equal to the derivative of u with respect to theta times the derivative of gen with respect to u. And this will give us 3 times minus cosecant of 3 theta minus 4 times cotangent of 3 theta minus 4. And that will give us minus 3 cosecant of 3 theta minus 4 times cotangent of 3 theta minus 4. Remember that I said the cosecant can be written as CSC. If you want to write it faster, you can write like that. If you want to write all, you can write. So where I've written CSC, you can put cosecant there, the same thing. Different books using different symbols. Yes. So that's why I've mixed them up. But once we have used this to write the question, in fact, I should have written that as what I have here. So I think there's no mistake. If you want to use this throughout, use it throughout. If you want to use CSC throughout, use it throughout. Don't mix it as I have done mine. Very simple. What did I say? I said that if you want to use cosecant written in this form throughout, use it throughout. If you want to use only the CSC throughout, use it throughout. I just mix it just to tell you that the CSC is the same as cosecant. So in this case, mine, I should have written here cosecant as this here. So don't mix it. Use one symbol throughout. Now let's take the next example. I think we've done this one too. So it has left with, let's take this one. I have m of x to be equal to tangent of 4x cubed minus 2x. So here, if I let p to be equal to 4x cubed minus 2x, I'll be using u, you can use any other variable. Then the derivative of p with respect to x is equal to 12x squared minus 2. If we differentiate 4x cubed, we get 12x squared. If we differentiate negative 2x, we get negative 2. Then now m of x is equal to tangent of p. Then the derivative of m with respect to p is equal to, if we differentiate tangent of p, we get secant squared of p. Wow. So this is the same as secant squared of p, and p is 4x cubed minus 2x. In fact, I've done the derivative of these two, the derivative of sine x and the derivative of cosine x from first principle. It is in the description, so you can check the description for the derivative of sine x and cosine x from first principles. Remember to like, subscribe, share, and leave your comments. So we have the derivative of m with respect to p. So here, m prime of x, that's the derivative of m with respect to x is equal to the derivative of p with respect to x times the derivative of m with respect to p. The derivative of p with respect to x is 12x squared minus 2. Remember to put it in brackets because we have two terms. Times secant squared of 4x cubed minus 2x. And that will give us 12x squared minus 2 times secant squared of 4x cubed minus 2x. Wow! And we are done, and we are left with the last example. The last example is cosine. So let's do one for cosine. Oh, this is very, very simple. So if I take y equal to cosine of 2x minus 1, I'm going to do it simple for you to be able to do it in section A. So the derivative of y with respect to x will be equal to take the inner function and differentiate it. So if I take the inner function, if I differentiate 2x minus 1, I'll get 2. Wow. Then if I differentiate cosine, what do I get? I'll get negative sine. Negative sine of what? The angle that is there. So I'll put 2x minus 1. Very, very simple as that. So the derivative of y with respect to x is now negative 2 sine of 2x minus 1. So check that. Take the inner function, differentiate it, and put the answer here. Then you take the derivative of cos. It will give you negative sine. Negative sine of what? The angle that is there. So you put the angle there. If you go through the chain rule, you get the same answer. Let's go through it. So let's say that we take u equal to 2x minus 1. The derivative of u with respect to x is equal to 2. This implies that we have y to be equal to cosine of u. The derivative of y with respect to u is equal to negative sine u. And what is sine u? We get negative sine of 2x minus 1. So the derivative of y with respect to x is equal to the derivative of u with respect to x times the derivative of y with respect to u. And this will give us 2 times minus sine of 2x minus 1. This is equal to minus 2 sine of 2x minus 1. Thank you for watching. Please like, subscribe, share, and leave your comments. Bye bye.